everybody, and welcome back. Today we'll continue talking about Chapter 4, Part 2, which is exception handling. When Python or any programming language has a runtime error, it stops the current execution and displays an error message. It raises an exception. As you can see in the below example, this is an example of an exception when you try to divide by 0. Runtime errors occur when the code basically works. In other words, no syntax errors. However, something out of the ordinary crashes the code. Some examples of those exceptions or runtime errors are when you write a calculator program and a user tries to divide a number by 0, and when you try to read a file and the file is missing, or you write the wrong file name. Also, when you try to perform a date calculation and the date provided is in the wrong format. All those are good examples of exceptions or runtime errors. Now in this example, we are creating a calculator program. It will take two numbers and divide them for the user. In this example, we are taking 6 from user and 2. The output will be 3. Everything is perfect. This is the ideal scenario. But what will happen if the user tries to enter 0 as the second number? So the program will try to divide by 0. In this case, your program will crash and it will display a runtime error, as you can see here. In order to avoid program crash, Python provides a very important feature to handle any unexpected error in your program and to add a debugging capability in them. So, what is an exception? An exception is an event which occurs during the execution of a program that disturbs the normal flow of the program instruction. In general, when a Python script encounters a situation that it cannot cope with, it raises an exception. An exception is a Python object that represents an error. When a Python script raises an exception, it must either handle the exception immediately, otherwise it should terminate and quit. How to handle an exception? If you have some suspicious code that may raise an exception, you can defend yourself and take precaution by putting your code inside a try block. After the try block, include an except statement, followed by a block of code which handles the problem as elegantly as possible. As we said, you can add a try except around the code that generates an error. To handle it in a simple way, here is a simple syntax of try except block. In this example, we are suspicious about division. We are worried that the user enters 0, so we cannot divide by 0. That's why we are putting the division inside the try block. The except block will be executed only if an error was generated. In this case, our exception is dividing by 0. Sometimes as programmer, we face the problem of program crash without us knowing exactly what's wrong, what's happening. So in this case, we may use the predefined method in Python called sys.executeInfo. This method will return the type of the exception raised. So this will help us to avoid this kind of exceptions and better handle them. There are a lot of different situations that can raise a runtime error. For example, converting between data types, opening files, mathematical calculations, trying to access a value in a list that does not exist. Here are the main types of exceptions in Python in the following table. You may visit this website to further understand them. IO error is input and output operation fails. This exception will be raised typically when you try to open a file that does not exist. Index error when you try to access an index that does not exist. Out of boundaries exception. Key error raised when a dictionary key is not found, and so on and so on. You can see the zero division error that we had an example about in the previous slides. Ideally, you should handle one or more specific errors and then have a generic error handler as well. In this example, we are handling only a specific error, which is zero division error. Also note that any code you place after the try except will always execute. For example, the last print in our example. This statement will execute no matter what. As we said, in Python, when you handle an exception, your program will never crash and it will continue executing the following statements. However, for some reason, if you want to exit your system after an exception, you need to add sys.exit. Now, in this case, the last print statement will only be printed, will only be executed if there is no exception, because if we have an exception, we'll exit the program. In Python, the except clause can trap multiple types of exceptions. For example, we have here two types of exception, type error and value error. When we try to convert none to float, we will get a type error. However, when we try to convert string into float, in this case, we will get a value error. Converting 1 into float will raise no exceptions. In this example, we have input-output exception. So as you can see here, we try to open a file. We put it inside the try block. If everything is perfect and no exception was raised, we'll continue executing the end of our program, which is starting from the for loop. We will go line by line and printing our file. Eventually, we'll close our file. However, if an error was raised, if an exception was raised, we'll go to the except block, except IO error as error. As error will hold the message, the details of the exception. So we will have more details about the error that was raised by our program. Then, if an exception was raised, we'll force our program to exit. One good example of input-output error is when we try to access a file that does not exist. How to catch improper input from the keyboard? We will use value error. So as you can see in this example, we are trying to read integer from the user. What if the user entered improper type, like string, for example? We will go to the except block and we will display you did not enter an integer, and in this case, we will exit our program. However, if everything went alright and the user entered a proper integer value, in this case, we will display the number that he had entered. This is an exercise. Kindly read it yourself and try to do it. An exception can have an argument, which is a value that gives additional information about the problem. The content of the argument vary according to the exception type. You will capture an exception's argument by supplying a variable in the exception clause as follows. We are using the variable e. So in this example, we are using exception. Exception covers all types of exception. It can be value error, type error, zero division error. So we do an exception clause that is general enough to capture all the exception types. And to know exactly which exception was it, we refer to the e message. It will give us further details about the exception. You can use an else clause in addition to except. The else clause will be executed only if no exception was raised in the try block. In this case, you don't need to use system.exit in the exception block. Sometimes you want to raise your own exceptions. You don't want to use the predefined exceptions in Python. So in this case, you will raise this exception inside the try and then catch it in the except block. So you can see in the following example, we don't accept number 10 for some reason, even though it is a normal integer. It's a proper value. However, I don't want to accept 10. In this case, I will raise a value error. Then we will go to the except block to display an error message for the user. As usual, the else will be executed only if you did not enter the except block. The last statement will be always executed, whether there was an exception or not. By doing those couple of exercises, you will evaluate your understanding on this chapter. That's all for today. Thank you very much and stay safe.